This is Jeremy Clark of JeremyBytes.com, and today we're going to spend a little bit of time talking about C-sharp generics. In particular, we're going to be talking about the difference between generic collections and non-generic collections, and this will help us get a better handle on why we care about generics in .NET. So let's start out with a definition. Generics are classes, structures, interfaces, and methods that have placeholders, type parameters, for one or more of the types that they store or use. Now, where we've seen this most frequently is in collections, so list of T is something very common that we see. We also may see them in interfaces, so here's an iRepository that has two type parameters, T and TKey. And we also may see them with methods. So here we have a get method that has a type parameter, and we see that that type is actually what's returned from this method. Now, why do we care about generics? Well, there's a number of benefits. The number one benefit that we get, especially in collections, is type safety. Generics are a compiled time enforcement of the particular types that we're working with. If we're not using generics, a lot of times we're dealing with object, the most non-specific type that we have in .NET. And that means we're often casting to object or casting from object to a more specific type. When we have generics in place, we don't need to do that casting. Another benefit is performance. When we talk about casting value types to reference types and reference types to value types, we end up with a process that's known as boxing and unboxing. This is very inefficient, and we can avoid it by using generic type parameters. A third benefit is flexibility and reuse. Instead of having to create separate classes, one for each type that we're dealing with, we can create a single class that has a generic type parameter and then use that with any types that we want. Now, there are ways to limit what types we can pass in, and we'll be looking at that in a future video. But today we're talking about collections, and you've probably seen this a lot of times. The .NET Framework has a class called list of T, and that T is a generic type parameter. What that means is we can replace that with any .NET type. Could be a class, could be a struct, could be an interface. Once we do that, now our list is restricted to dealing with just that type. When we create this variable list of string, that means that we can only add strings into this collection. And when we remove items out of the collection, they will be strings. So we have that type safety built into the collection. Now, we've been taking generic collections for granted since .NET 2.0. So we might not really understand what the differences are between a non-generic collection and a generic collection. Well, there are still some collections in the .NET Framework that do not use generics. So let's look at some code so we can really see the differences between a non-generic collection and a generic collection. So here we are in Visual Studio, and we're going to take a look at the difference between a generic collection and a non-generic collection. Let's just run our application to see what we have right now. So we see we have buttons for non-generic list and generic list. We also have a repository button, but we won't be worrying about that button today. And then we have a clear data button, which will clear out our data. On the right-hand side, we have a list box, and that's where we're going to display the data from our lists. So let's look at where our data will be coming from. Inside our generics.common project, we have this people class. And we can see this is a static class that has two static methods, one called getNonGenericPeople, which returns an array list, and one called getGenericPeople, which returns a list of person. Now, array list is a non-generic collection, and what that means is every type inside the collection is stored as type object. So we can put anything that we want into the array list. Conversely, list of person has a generic type parameter that says this list will only accept items that are of type person. So let's take a look inside these methods. If we look inside our getNonGenericPeople, we see we have a variable called personList, which we're newing up as a new array list, and then we're populating this with a series of person objects. If we right-click on our person and go to definition, we can see that this is a very simple class. It just consists of 4 properties: a first name, a last name, a start date, and a rating. Once those objects are created, it just returns the list at the very bottom. Now, if we take a look at our other method, getGenericPeople, this will look almost exactly the same. In fact, the only difference is that instead of newing up an array list, we're newing up a list of person. The items that we're putting into the list are exactly the same as we have in our other method. So let's see how we'll actually use these in our application. We'll go to the code behind for our form, and we see that we already have button click event handler set up for our non-generic button and our generic button. So let's start by implementing the non-generic list. So here we have an array list, and we'll call this people, and what we'll do is just call that get non-generic people method. So we'll say people.get non-generic people. And again, this method actually does return an array list. So now that we have this array list called people, we can iterate through it. Now, pretty much every collection in .NET implements the IEnumerable interface, which allows us to use the for each loop. So we can say for each person and people, person listbox.items.add person. Now, var is just a shortcut. When we look in here, this is type system.object. Again, that's because ArrayList only holds object types. So let's go ahead and say object here, just so that we're a little more explicit in what's actually happening. Now, if we run our application and click on our non-generic list button, we see that our list box is populated with the 7 items from our collection. So let's do this same thing with a generic collection. And what we'll see is that the code is almost exactly the same. So here we'll say list of person people equals people.getGenericPeople. And again, if we look at the getGenericPeople method, it does return a list of person as the type. And just like with our other collection, we can for each through this. So we can say for each person and people, person listbox.items.add person. And when we run the application, there really should be no surprise when we click on generic list, we get exactly the same results that we had from the non-generic list. And just like we did with our other collection, if we look at this var that's coming out of our for each loop, notice that this is of type person, generics.common.person. So just like we were explicit above, let's go ahead and change this to person so that we're explicit here as well. So now we have 2 different collections that do exactly the same thing. So what you're probably wondering is, why should I use one over the other? This is where the type safety really becomes key. Up here with our array list, we can put whatever we want into this collection. So I can take our people collection and say .add hello. I can also say people.add 42. And when I build my application, the build is successful. There are no errors with this. But what happens when we run the application? Well, if we click on the non-generic list button, notice that we have 2 empty members. These are actually the items in our collection for the hello string and the 42 integer. It turns out that WPF data binding is extremely forgiving. What that means is it doesn't care what object we throw at it as long as it has the properties that it's looking for. So in this case, it's looking for a first name property, a last name property, a start date property, and a rating property. Well, a string doesn't have any of those, so it ends up just displaying an empty item. And if you ever need to troubleshoot data binding in XAML, you can go to the output window. Now notice what we have down here in the output window. Let me scroll up a little bit. And we can see these binding expression path errors. So we see start date property not found on object string. First name property not found on object string. So we actually have error messages for each of those. And then if we scroll down, we'll see we have exactly those same error messages for int32. Start date property not found on object int32. Now you may be noticing that start date is actually on there twice. That's because in our application, the background color is actually tied to the start date. So we're actually data binding to that property two separate times. Now again, since this data binding is failing, we get inconsistent results at runtime. We'd really like to eliminate some of that. What can we do in our application? Well, we can be a little bit more explicit. We can change our for each loop so that instead of iterating through and pulling out objects, we ask for objects of type person. Now, what will happen in this case is each item will be cast to a person as it comes out of this collection. And again, what we'll see is we do not have any compile time problems. If we build this application, it builds just fine. When we run our application, we will get runtime errors, but they're going to be a little bit different than what we saw before. We're actually going to get a runtime exception. And if we look at the value here in the additional information section, we see it says unable to cast object of type string to type person. So as we're pulling the items out of this array list, we're trying to cast it to a person object so that we can display it in our UI. The string hello is obviously not a person, so that cast fails. Now we could keep trying to put in safety measures to try to get this array list to work, but that's really throwing good code after bad at this point. Instead, we really should be using a generic collection. Let's look at what happens when we try to add non-person objects to our list of person. So we'll use the same code we have above. So we'll say people.add hello and people.add 42. Now notice immediately our development environment is not at all happy about this. And if we tried to build our application at this point, we will get build failures. And if we look at the error messages, we see we have one cannot convert from string to person. And we have another one cannot convert from int to person. So in this case, because we have that generic type parameter, we have type safety in our collection. We're not actually allowed to add anything that's not a person to this particular list. And what that also means is that as we're pulling items out of the list, we can be confident that they are person objects. So even if this person in our for each loop was an actual cast, we could cast that safely because we know everything in there is a person. But we actually don't have to do a cast because of the generic parameter type. Everything that comes out is automatically typed as a person object. So here we've seen how generic type parameters really help us with collections. In this case, with our list of person object, we know that everything coming out of this is a person object, so we can confidently use it in our UI and know that it will data bind appropriately. In addition, we know that we're not allowed to stick anything into this list that's not a person object. That means if we do try to do something that we're not allowed to do, it will actually be caught at compile time rather than runtime. When I have a choice between compile time errors and runtime errors, I take the compile time error every time. So that's it for our first look at generics using collections. Now there is a lot more to learn about generics. In future videos, we'll be taking a look at how generic type parameters work with interfaces and how generic type parameters work with methods. And if you don't want to wait for those additional videos, you can look at the links for this video, and there's actually a PDF walkthrough that will take you through all of these samples. So for more information, including the code download and a PDF walkthrough, be sure to visit www.JeremyBytes.com.